Hi there, welcome to Eko Learners Support for WAEC and NECO candidates. Today's class is going to be very interesting. I am your chemistry instructor, Rashid Jima. Now, before I turn to the screen, I would like to find out if you can guess your way into what we will be learning today. I want you to picture that you have a car. You have a wedding ring. You have a coin. You have cables. You have rods that are used in construction. What do all of these have in common? Very correct. They are all transition methods. And that's exactly what we are going to learn today. So, get your exercise book and write the topic and today's date. Transition method. As you can see there, these are elements that are occupying the D block in the periodic table. We've set these learning objectives to guide us. 1. At the end of this lesson, you should be able to understand the position and properties of transition methods in the periodic table. 2. You should be able to explain the significance of d orbitals in transition methods. And lastly, you should be able to describe the real-world application of some of these transition methods. But before we go further, let's look at some keywords that will guide us. Transition methods. Like we said, these are elements that occupy the D block in the periodic table. D orbitals. Yes, this is another type of orbital. Don't forget, we have the S, we have the P, and we also have the F orbitals. Oxidation state. This is the charge on an atom. And we have complex ions. These are the type of ions that are formed by transition methods. Let's dive in. Let's inspire ourselves with this quote by the world famous Albert Einstein. It says, "The important thing is to never stop questioning." I hope that this quote will inspire you to continue to ask the right questions, to be curious, because that is one of the essential skills of a great scientist. So what are transition methods? Let's find out. Transition methods are a block of elements that are between the group 2 and group 3 of the periodic table. They occupy a stretch of elements starting from scandium, to zinc. These elements in red here are all called transition metals. Transition metals have different properties from the group 1 metals. If you look at the group 1 metals, for example, sodium, it has a fixed oxidation state. The oxidation state of sodium is +1 in all its compounds. This is not the same for transition metals because they have what we call variable oxidation state. For example, iron here can have an oxidation state of +2 and +3. This is one way by which transition metals differ from the main group metals. Also, transition metals are colored. They form colored compounds, unlike the main group elements that are usually white or colorless. So, let's go ahead. These are some images of transition metals that you can find around us. That is chromium. We have manganese. Here is copper. Yes, the same copper, which is a conductor of electricity. That's what the cables are made of. Although copper is not the best electrical conductor, the best electrical conductor is silver. But because silver is expensive, copper is the second best. Iron, cobalt, nickel. So these are common transition metals. And you can see that they are brightly colored. Now, the IUPAC defines transition metals as elements with an incomplete D subshell, or element that can form a cation with an incomplete D subshell. Now, the emphasis here is that before you can call an element a transition metal, it must have incomplete D orbital. Or you can describe it as having partially filled D orbital. Now, this nomenclature is very important because some transition elements are exceptions in terms of behaviors to what a typical transition metals are. For example, if you look at the likes of zinc, unlike most transition metals, the D orbital of zinc is completely filled, and that's why it has D10. So this doesn't satisfy what the requirement is for an element to be a transition metal. You can call zinc a D block element, but not a transition metal. That distinction has to be made. Let's move on. Now, how do you write the electronic configuration of transition metals? They are quite different from the way you write the main group elements, because you are now filling electrons into the D orbital. Now, what you have here shows the electron configuration of the first transition series, starting from scandium to zinc. Of note is what you have at chromium. You can see that from scandium we begin, to fill the S2 and then D1. That's 21. Scandium is 21. So argon here is 18. So 18 plus 2 electrons, that is 20. And then the 21st electron goes into the D. That continues until you have an exception here for chromium. You can see that here the S orbital is partially filled, and then the other electron goes into what? Into the D. Instead of this to be 4s2 3d4, we're now having 4s1 3d5, meaning that the S orbital is incomplete before we start filling the D. That is an exception to how transition metals have their electron configuration. The same is also noticed here for copper. It is important that you take note of this, because in the exam you can be asked to write the electronic configuration of any of these transition elements. So for copper, you can see we have 4s1 and then 3d10. Normally what we should have is 4s2 3d9. So please take note of this exception. You can see we fill the S partially before we go ahead to fill the D. So that has been explained in the earlier slide there. Let's move. Now, physical properties of metals. Metals generally have the following physical properties, whether transition or main group metals: malleability, ductility, ability to conduct electricity. Now, in addition to all of these general properties of metals, transition metals have some unique properties. What are these unique properties? One, they have partially filled D orbitals. We cannot overemphasize this point, because most of the reactions of transition metal is as a result of the partially filled D orbital. So the D orbital is not completely filled. And when we talk about the d orbital, okay, in the d orbital, it can accommodate up to 10 electrons. And because electrons love to be in pair, so we are going to divide the d orbital into 5 partitions. So for example, if you have an element like scandium with 21, okay, well, it's going to be 3d1, just 1 electron there. So this is partially filled because we still have 9 more electrons to fill this. But there are other elements, for example, zinc, 30, okay, if you draw its own orbital diagram, okay, so apart from once you end at calcium, which is 20, okay, then you are going to have 3d10. 3d10. That means there are now 10 electrons in the d orbital. So that will be 1, 2, 3, 4, 5. And then we start pairing 6, 7, 8, 9, and 10. Now, we are going to explain the significance of having a partially filled d orbital and having a completely filled d orbital in the other properties. 2, they have variable oxidation state. Like I said earlier, iron, for example, can be +2, it can be +3. The reason for having variable oxidation state is that the transition metals can either use the s orbital or the d orbital in forming bonds. They are paramagnetic. Paramagnetic means that they are attracted to magnets. But not all transition metals are paramagnetic. Some are diamagnetic. Now, what is responsible for paramagnetism is the presence of at least an unpaired electron. My dear student, yes, an unpaired electron. What we mean by an unpaired electron is an electron in an orbital that is standing alone, singly, is not paired up. For example, what you have in scandium here, this is an unpaired electron. The more the number of unpaired electrons, the more paramagnetic the transition metal is. But diamagnetism occurs when all the electrons are paired up. For example, what we have in zinc, you can see all the electrons are paired up, and so this is diamagnetic. So when a transition metal has D0 or it has D10, it becomes diamagnetic. There's another term which is also attributed to magnetism. We call it ferromagnetism. Some metals are ferromagnetic, and these are metals that are strongly attracted to magnets. Examples include iron, cobalt, and nickel. You can actually use FECONI as an acronym to be able to remember the ferromagnetic metals. These ones are natural magnets on their own. All right, now they form colored compounds. Most compounds of transition metals are colored. Okay, you're going to see some of those compounds shortly. They are used as catalysts. Most industrial reactions are catalyzed with transition metals. For example, in the EBA process of ammonia, we use finely divided iron. In the contact process of H2SO4, we use vanadium pentaoxide. In the hardening of vegetable oil, we use nickel. So you can see that all industrial reactions are usually catalyzed, and the catalysts used are the transition metals. Lastly, they form complex ions. Transition metals sometimes have empty d orbital, and this serves as a space for a ligand to be able to attack. You can check up for the meaning of a ligand. So let's move. Now, just to take home some of these properties, variable oxidation state. Now, I hope you are familiar with this gentleman. He is a popular musician in Nigeria and also an actor. Now, this is an example of what we call variable oxidation state, when a particular atom or a metal can actually change its state You can see Saheed Osupa here being the actor on scene and also being on stage performing. It can be an actor, it can be a musician. So transition metal can have variable oxidation state, +1, +2, +2, +3. They can change their states. These are some examples of the colored compounds formed by transition metals. Some of them are manganese, chromium, cobalt, nickel. They usually form colored compounds. This is because whenever they are exposed to light, there is excitation of the electrons, and the moment the electrons jump, they absorb energy with them. This energy corresponds to a particular color with wavelengths, and this is what imparts color into the transition metals. Magnetic properties I've already explained, and you can see that paramagnetism is as a result of at least one unpaired electron. This is usually very examined, paramagnetic behavior of transition metal. The presence of at least one unpaired electron that is standing singly in the orbital, will make that transition metal to be paramagnetic. But if all the electrons are paired up like this, what you have there is diamagnetism. Now, catalytic action, which I've already explained. What is a catalyst, my dear student? A catalyst is a substance which increases the rate of chemical reaction by doing two things. One, it provides an alternative pathway for the reaction to take place. Two, it lowers the activation energy. In fact, it does the first one before the second one. It lowers the activation energy, thereby providing an alternative pathway for the reaction to take place. And that way, the reaction is faster. And you can see an image here showing you hardening of oil, how vegetable oil is converted to margarine. This is just by bubbling hydrogen to the oil and using nickel as the catalyst. This is how the margarine that you take at home is produced in the industry. So, we've already explained what a catalyst is and what it does. Now, I challenge you here. You have two alternatives of reaching home from school. This is one route, this is another route. And I ask you, if we label the first route A and the second one B, which of these routes do you think you will follow and you will get home faster, and why? I want you to pause this video right now, reflect on this question, and be ready to share your answer with me.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Welcome back. So, which of these routes would you rather follow home that will make you get home faster? Did you say route A? Why did you go for route A? I think it should be route B, because if you look at route A, you have a lot of hill to climb, and this is going to slow down the reaction. This is an energy barrier. So you can refer to A as an uncatalyzed reaction, a reaction that a catalyst has not been added to. Now, the moment you add a catalyst to a reaction, what it does is that it brings down the activation energy. The activation energy is the minimum amount of energy required for reactant particles to form product. And that's why you can see a lower activation energy here. That way, the reaction proceeds faster. This is what a catalyst does. It lowers the activation energy and creates an alternative pathway for the reaction to take place, rather than the car going through this very difficult route, it provides an easy alternative for it to take. So these are other characteristics of catalysts. They are recovered at the end of a reaction. Okay, they are required only in small quantity. They lower the activation energy. They increase the rate of reaction. They are affected by temperature. They are affected by pH. They do not have anything to do with the equilibrium constant of a reaction. Alloys. Alloys are simply mixture of two or more metals. For example, bronze is made by mixing copper and tin. This is usually examined. Please take note, there's a difference between bronze and brass. In bronze, it is copper and tin, but in brass, it is copper mixed with what? With zinc. These are other alloys that you can have. There's a common alloy which is usually also examined. It is called duralumin. Yes, say that. Duralumin. As the name suggests, alumin is part of the name, and so one of the metals making it up is aluminium. Another is magnesium, manganese, and lastly, you have copper. There are 4 metals that are mixed together to form duralumin. Duralumin is very important in the aerospace industry. The bodies of aircraft are actually made with this special alloy, and because it is very, very light, and you know aeroplane has to be light. So that is for the alloys. Let's quickly run through the uses of transition metals. I've already said they are useful as catalysts in most industrial processes, and these are examples: iron in EBA, nickel in hydrogenation of oil, rhodium and platinum in catalytic converter that is used to reduce pollutants in the environment. We have vanadium pentaoxide in contact process of making tetraoxosulfate 6 acid. Iron is another very useful transition metal. It is very hard, it is strong, and is abundant. In fact, Nigeria is richly blessed with iron. We have huge deposits of iron in Ajaokuta. Okay, iron is used in construction works. Titanium is as strong as steel, but even much lighter. So that is a desirable property there. And it is very resistant to corrosion. So it can be a substitute for iron. So it is used in aerospace industry and also in artificial joints, such as the hip joints and sockets. Titanium dioxide is also a brightly white compound that is used in paints, in plastics, in paper, and of course, in toothpaste. Another very useful transition metal is copper. Like I said earlier, copper is used in cables, which is used because of its very good electrical conductivity. Now, let's practice with these model questions. Are you ready? Of course you are. Let's go. The first question says, transition metals can form complex ions because A, they have paired electrons in the d subshell, B, they have unpaired electrons in the d subshell, C, they have empty d orbital, and D, they have small charge to size ratio. Why do you think transition metal form complex? If you remember, in the earlier discussion, I told you about formation of complex ion, and this is because transition metals usually have empty d orbital, which a ligand can attach to. So the correct answer here is option C. Option C is the correct answer. It is because they have empty d orbital. Let's look at what the second question looks like. What is the catalyst that is used in the contact process of H2SO4? You are right. The correct answer is vanadium pentaoxide, V2O5. Let's look at the third one. The third one says transition metal atoms without unpaired electrons are said to be what? If there are no unpaired electrons, that means all the electrons are paired up. How do you describe such transition metals? Fantastic job. They are what? They are diamagnetic. So the correct answer here is diamagnetic. I'm really proud of you. Let's look at question 4. Transition elements usually exhibit variable oxidation state mainly because what? They are metals, they are employed as catalysts, their d electrons are involved in bonding, they have high melting and boiling point. The correct answer here is option C. This is the reason why transition metals have variable oxidation state. Remember I said you can either use the s orbital or the d orbital to form bond. And lastly, the following describe the properties of transition metals except A. Formation of colored ions, B. Constant oxidation state, C. Formation of complex ion, and option D. Catalytic ability. What do you think? Did I hear you say option B? Option B, yes, is actually correct because transition metals have variable oxidation state, not constant oxidation state. You can see how the examiner can play with your intelligence to see whether or not you truly understand this topic. Okay? And we have now come to the end of this particular lesson. I hope that now you are confident going into the exam to be able to answer questions relating to transition metals. In this lesson, we have looked at transition metals, we've looked at properties of transition metals, we have also looked at everyday applications of transition metals.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
I enjoy you to leave your comments, your feedback, your suggestion using the link displayed on the screen. Before next time, when I see you in class, keep accelerating. Bye for now.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors. Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.